Okay, so let's look at the question here. A metal block hangs vertically from one end of a spring. The other end of the spring is tied to a thread that passes over a pulley and is attached to a vibrator as shown in figure 4.1. So you can see this is the vibrator, so attached to the pulley and then spring and then the block. So A, the vibrator is switched off. The metal block of mass 120 gram is displaced vertically and then released. The variations with time t of the displacement y of the blocks from its equilibrium position is shown in figure 4.2. So from the graph, we understand that it starts from -2, so meaning that this is the equilibrium position, so you have to pull it down by 2 cm, then you release your hand, then it oscillates upwards, downwards, upwards, and so on. Okay, so let's look at the next part. For the vibrations of the block, calculate the angular frequency, omega. So angular frequency, omega, is 2 pi f, or 2 pi 1 over period. So 2 pi, so the period, let's find out the period. Let's say from minimum to minimum. So it takes 0.6 seconds. So that is the period, 0.6 and 10.5 radian per second. Okay, so this is part 1. Now let's look at the other side. Part 2, the energy of the vibrations. So to find out the energy of the vibration, so the formula is E total equal to 1 over 2 m omega square maximum displacement square, that is amplitude. Okay, so 1 over 2, the mass is 120 gram, the omega is 10 point, so this is actually 10.47 if I keep the decimal. So I will use 10.47 to make it more accurate. Okay, so 10.47 square, and then the maximum amplitude, as you can see here, -2. -2, of course, the maximum amplitude, we don't care about the negative, and it's 2 cm, so which is 2 times 10 to the power of -2 square, and then we will get 2.63 times 10 to the power of -3 joule. So this is the energy, the total energy. Okay, now B, the vibrator is now switched on. The frequency of vibration is varied from 0.7 F to 1.3 F, where F is the frequency of vibration of the block in part A. Okay, so for the block, complete figure 4.3 to show the variation with frequency of the amplitude of vibration. Label this line with A. Okay, label this line A, capital A. So, okay, now what we have here is we have two situations. The first situation is the original one. Okay, the original one is where we have the frequency as in part A. Okay, so F. So F is 1 over 0.6. Okay, so of course, what value is that? No need to care. If you want to count, just go ahead. 1 over 0.6. And then the amplitude is let's say the amplitude we know also. The amplitude is this value, okay, 2 times 10 to the power of negative 2. Okay, so we draw out that graph. So the frequency is F. The amplitude, let's say we just put it, okay, so okay, we just put it anyway. Let's say because there is no value here, so just put it anyway. Let's say we put at the highest point here. Okay, so then it will just be like this. Okay, so the graph is like this. This is for A. This one I call it A. Okay. Okay, so of course over here you have to know the amplitude is 2 times 10 to the power negative 2. Okay, so now let's see the next page. So on the next page, right, I just keep it like this first because we need to draw the graph over here. So I just read out the questions. Some light feathers are now attached to the block in B to increase air resistance. So imagine about that, huh? Increase air resistance. Okay, so the frequency of vibration is once again varied from 0.7 frequency 0.7 F to 1.3 F. The new amplitude of vibration is measured for each frequency. On figure 4.3, draw a line to show the variation with frequency of the amplitude of vibration. Label this line B. Okay, so first of all, we have to know if you put feather on the block, so of course it increases the air resistance. So we should expect period the period to be longer. So the period should be longer. If you put feather, okay, part C, you put feather on the block, so it vibrates slower because of air resistance. So air resistance is getting greater, and then the effect is the period should be greater. It takes longer time to make one complete oscillation, and then the frequency should be lower. So that is the effect of the feather. So in that situation, the frequency should be lower. Okay, so uh, you know, currently we are doing it in F. Okay, in F. So the resonance happen at F. So now the frequency is lower. So we should put it at somewhere before it. Let's say just anywhere here lah. Okay, anywhere over there. So okay, what value they don't really mind, as long as you know the frequency is lower. And if the frequency is lower, so what happens is the graph will shift to the left, the peak will shift to the left, and then the amplitude will get lower all the way. So it's always lower than the original one. Okay, so it's something like this, and this is called B. Yeah, so just like that. And of course, 2 marks is given for this part C. So just now I don't look at this part. So, but we have done this part actually. Okay, so it's just like that. And okay, so settle for these questions.